Hello and welcome back to the beach. Today what we're looking at is normal probability distributions. See, there's so much fun on my beach. You should be here with Beach Shack. So what we're going to do to start with is we're going to have a look at some averages, and then we're going to start getting into how the normal probability distribution curve works and what it's trying to tell me when you see this type of curve. So to start with, we've got three different types of averages. The first average that we have is what's known as a mean average. The mean is multiplying the number of occurrences by the result and then averaging it all out. What you may see within this type of situation is, and we've seen this within regression analysis sessions already, if you've got an X or a Y and there's a straight line above the top of it, that means mean. And what that says to me is you find the average by multiplying everything through and then dividing it by the number of occurrences. Don't worry, we've got an example. We'll illustrate how this works. Next, what we have is the median, and the median is the number which is halfway through the set of data that we've collected. So we've got the median, which is the number which is halfway through the set of data that we've collected. Then we have the mode, and the mode is the number that occurs most frequently within that set of data that we have collected. Ed, I don't get this. This is hard. Let me just go and sit on the beach with the beer and the sunshine. Right, let's have a look at an example. So what we have for you guys is we have an example, and the example is a very simple example to start with, and then we're going to start making it a little bit more funky. So we are looking at sandwiches in the sand. So how many sandwiches do people eat when they go to a party? If we've invited a large number of people to our party, we can work out how many sandwiches they have on average, and then try to work out how many sandwiches we need to provide in the future. So we're looking at how many sandwiches do people eat on average within this party. Well, the amount of data I've collected here, it looks really, really useful and really powerful. I've got no idea how to use it. So let's try and find a way how we can actually potentially use it. The first thing I'm going to do is I'm going to work out how many different people have turned up at this party, and I'm going to work out how many sandwiches have been eaten in total. So what I'm going to do is I'm going to add in an extra column. So I'm going to add in an extra column, and the extra column is going to be this bit over here. Let me get this laser pointer going. So I'm looking at the sandwiches multiplied by the number of people over here. So this is the bit which is suddenly very interesting to me. So the sandwiches eaten at the party and the people eating that number of sandwiches are actually given to me because I can collect that data. So all of that is known with an element of certainty. I then multiply this through. If I now try to identify what the mean, median, and mode is going to be, I can work it out based on this set of data. Now remember, the mode is the number that occurs most frequently within the set. So here's my set of data here. Which number occurs most frequently? Well, it's the number 12 is the one that gets done most often. It gets done 12 times. So that means it's number 2. So most people will on average eat 2 sandwiches. That becomes my mode, okay? The median becomes, well, I've got 40 people here going from top to bottom. If I start at the top and work my way down, how far do I get before I get to my 20th person? 4 plus 6 is 10 plus 12 is 22. So that now means that the median is going to be 2 sandwiches. Okay, so my mode is 2 sandwiches and my median is 2 sandwiches. Surely that now means the best average must be 2 sandwiches. Not quite, because now what we do is we look at the mean, and the mean looks at this total of 96 sandwiches consumed in total by 40 people, and that now says to me that the average number of sandwiches eaten based on the mean is going to be the 96 divided by 4. Now this mode and median can both be used for forecasting techniques. However, the mean is a little bit more accurate. So the mean becomes more accurate because it means, no pun intended, on average people will eat 2.4 sandwiches. So we have a large number of people coming along to our parties. It now means we need to have on average 2.4 sandwiches for each person we invite along to our parties. Okay, that sort of makes an element of sense, guys. So yeah, that's great. I now know how many sandwiches I need to make. Obviously, there's going to be an issue with size of the sandwiches and the things that are actually with the fillings within sandwiches. But on average, everyone's eating 2.4 sandwiches. There are other things that we can fire in here, guys, as well. And from a statistical perspective, we talk about things such as the range. Now, the range is the highest value less the lowest value. And it gives you the total spread of every single actual result. So this will give you the total spread of every single actual result. What also happens here is we can look at what we call the standard deviation. And the standard deviation allows me to see how spread out. So the standard deviation allows me to see how spread out the actual results are from the middle answer. And the middle answer here being my mean. So if you've got a large standard deviation, it means they're going to be more spread out. If you've got a low standard deviation, it means that they are less spread out. Now, this standard deviation comes about because we put together what we call a normal probability distribution curve. And this is my bog standard normal probability distribution curve. Now, this normal probability distribution curve, I'm not going to say that anymore, guys, also known as the Gaussian distribution curve. It's a probability distribution which is symmetrical around the mean. So here's my mean in the middle. There's my line up the middle. And it means that everything on the left-hand side is symmetrical to everything on the right-hand side. So everything is supposed to be a nice even curve. Okay? What it shows you is data near the mean. So any type of occurrences around here by the mean, they are more frequent. They've got a greater chance of occurring because the area within the graph, so the area within the graph around the mean is highest. So that shows me that I've got a bigger chance of getting a number within this area here than I have of getting something which is really, really short or really, really tall. So if I think about this in terms of height of individuals, you'll tend to find that the vast majority of people will be around average height plus or minus an extra bit. You're unlikely to find somebody who's very, very short. You're unlikely to find somebody who's very, very tall. The majority of people will be closer to the mean, which means that you can now potentially forecast what you think is going to happen in the future based on this mean, because that's the most often number that's going to occur. Okay? So the middle point of this normal distribution is the point with the maximum frequency. This means it's got the greatest chance of occurring. So it's got the maximum frequency, the greatest chance of occurring, and that now means it possesses the most amount of actual observations. Now, this normal probability distribution curve looks like a bell. It's supposed to look like a bell. And what also happens here is the area to the left-hand side of the mean, so from this line on the left, all of that is 50% of all of the occurrences. All from that line onto the right, all of that is 50% of all the occurrences as well. Now, okay, Ed, I sort of make a basic understanding of that, but you said this is going to tell me about the spread. Now, at the moment, that just looks like a pretty picture. Now, what we're going to do is we're going to put two different bell curves together, so two different distributions together. And what we've got is the red curve and the blue curve. Now, I appreciate they're not the prettiest lines in the world, but they are designed to specifically illustrate something quite simply, hopefully, and quite cleverly. The width of the bell curve, so the width of the bell curve, so how wide it is, that is known as my standard deviation. So the width of the bell curve is my standard deviation. Now you should be able to see here that the width of this bell curve here, the red one, is actually quite narrow, whereas the width of the blue bell curve is quite wide. Okay, which means that the red curve has got more occurrences around the mean. So the red curve has got more occurrences around the mean, which means there is less deviation from the mean. So there is less deviation from the mean. So the red curve has got less deviation. The blue curve has got more deviation. Now what you can do here, guys, is you can actually apply risk analysis to this. And you can say that this now means that the red curve has got less risk. The blue curve has got more risk. So the red curve has got less risk, the blue curve has got more risk. Risk from what? Risk from deviating from the mean. So the red curve has got less risk of being different from the mean. The blue curve has got more risk of being different from the mean. Oh, okay, that now means I can apply my analysis of my own personal risk appetite and work out whether I want more or less risk, and then use this from an investment portfolio perspective. And that's what we actually do. Now, every single normal probability distribution curve is set up in such a way that we have this type of bell curve, and 95% of all occurrences fall within the mean plus or minus 2 standard deviations. So it's the mean plus or minus 2 standard deviations. Now the red curve, as you can see here, has got a more pronounced bell, and therefore it's got more occurrences very close to the mean. Therefore it's got a smaller standard deviation and it's got lower levels of risk. Whereas the blue line is more spread out and the bell curve is not so pronounced, meaning that there are more occurrences further away from the mean, which means it's probably going to be higher risk. Okay, now this type of normal probability distribution curve looks like it's something which has just been artificially put together, but in the real world, even in nature, this works really, really effectively. So if you were to look at things such as the weight of individuals, the height of individuals, lots of other things in nature, all of these things will follow a normal probability distribution curve. It is a very, very powerful curve. It's the type of thing which gets used in nature all of the time, all of the time. Now, another way that we can potentially measure the spread is we can use what we call the coefficient of variation. Now, the coefficient of variation is the standard deviation that you already have, and you're going to express that as a percentage of the mean. So standard deviation divided by the mean, and it's then just expressed as a percentage. The higher the coefficient of variation, the bigger the spread. So the higher the variation, the bigger the spread. So in our example before, the blue line will have a bigger coefficient of variation. The red line would have a lower or a smaller coefficient of variation. Okay, thank you very much for your time and attention, boys and girls. All that talk of sandwiches now makes me want to go and have some sandwiches. So let's go and get some lunch. Thank you very much for your time and attention. Thank you for joining me on the beach, and I'll see you all very soon. Take care. Bye-bye for now.